Hello, we are going to practice writing quadratic functions in standard form given some coordinate points. So if we look at this first example, we're writing the equation of the quadratic function in standard form. And just as a review, standard form is ax squared plus bx plus c. So we need to get it in this form. And the information that we're given is that it has a vertex of -10, -1, and it passes through the point -11, 1. Okay, so if we notice a few things, it's given the vertex. So if I give you the vertex, the first thing you should ask yourself is, what form should I start in? So if you think about it, it should be vertex form. Right? So that is a times x minus h squared plus k. From this form, we know our h and k from our vertex, but the piece that we're missing is the a. The reason why we're given the a, or the reason why we need to find the a, is because we can't just guess what it is, since we are given it goes through this point. Since we know it goes through this point, we know this is x, comma y. We can substitute in this point for the x and the y, which is actually our f of x. So we can substitute those in, as well as our information from our vertex, and solve for a. So that's what we're going to do first, is substitute in the information we know from our vertex. So we'll have f of x equals, don't know our a. If it's a -10 in our equation, it becomes the opposite. So plus 10 squared, don't forget the squared, and -1. So that's just from knowing our vertex. But now we can substitute in our point, x and y. So for y, that's the same as f of x. So 1 equals a, substitute -11 in for x, plus 10 squared minus 1. So now let's simplify to find out what a is. Order of operations tells us to do parentheses first, so we're going to simplify that. So we'll have 1 equals a, and then -11 plus 10 is -1. Don't forget the squared. You have -1 on the outside. And from here you have 1 equals, next thing is exponents. So we'll have a, and -1 squared is 1. And you have -1. Well, 1 times a, if you wanted to write it as just a, that's totally fine. So if we wanted to write that as just a, that's okay. From here, to get a by itself, you add 1 and add 1. So that'll give you an a value of 2. Now that we have our a value of 2, we can take this and substitute it into our equation, which will give us f of x equals 2 times x plus 10 squared minus 1. Now this is awesome. This is in vertex form. We're off to a great start, but we need it to be in standard form. So in order to do that, we need to multiply this out first and simplify the whole thing. So what this is going to look like is 2, and since this is squared, what that means is you take your factor and you write it twice. From here, I would recommend to distribute this out. So take your x, distribute it to x, so you'll get x squared, x to 10 to get 10x, and then do 10 to x, 10x, and then 10 to 10 would be 100. Simplify this first before you do anything else. You still have your 2 on the outside. You'll have x squared plus 20x plus 100 when you combine your like terms. Don't forget about this -1 on the outside. Notice how I left this in parentheses. That's because this 2 was being multiplied by the x plus 10 squared. So that means when we multiply it all out, we still have to multiply this 2 to each term here. So when we do that, we'll have 2 times x squared, which is 2x squared, and then 2 times 20x, which is 40x, and then 2 times 100, which is 200. And then don't forget, you still have this -1 on the outside. Almost there in standard form. We just have to combine the 200 and the 1. So our final answer will be 2x squared plus 40x plus 199. So there is our final answer. Okay, let's try one more, but this time we need it to be in standard form. And I'm giving you zeros of 2 and -3. That passes through the point 1, 2. Now, we still need to end up in ax squared plus bx plus c form, standard form. But what form should we start in? Well, we're given the zeros. And if you recall, our options are standard, vertex, or factored form. And the form that reveals the zeros is factored form, which is f of x equals a times x minus r1 times x minus r2. And the r stands for roots, which is another word for zeros. So from here, just like last time, we can substitute in what we have, what we were given, x, and if it's minus r1, that means it's the opposite of what we see, -2, then opposite of what we see, x plus 3. And from here, we can substitute in our x and our y. So we'll have 2 equals a, and now this 1 is going to go in both spots. 1 minus 2, 1 plus 3. Just like last time, order of operations says to do parentheses first. So 1 minus 2 is -1. 1 plus 3 is 4. Next we multiply. So a times -1 times 4 is -4a. To get a by itself, we divide by -4, divide by -4. So a, when we simplify 2 over -4, is -1/2. And it's okay to get a fraction. Fractions aren't necessarily a bad thing. That just means our quadratic is compressed instead of stretched. So we take our a value next and substitute it in, just like we did last time. So we'll have f of x equals -1/2 times x minus 2 times x plus 3. So this is in factored form, but we need to get it into standard. So just like last time, we multiply it out. Keep the -1/2 on the outside for now. We'll deal with that later. X times x is x squared. X times 3 is plus 3x. -2 times x is -2x. -2 times +3 is -6. Now we can simplify by combining our like terms here. We'll have x squared plus x, or 1x, minus 6. Almost there. We just got to distribute the 1/2 to each term to get rid of our parentheses. And that will give us our f of x equals -1/2 x squared minus 1/2 x. -1/2 times -6 is a +3. And if you wanted to write these as decimals, that's totally fine. I'm going to keep mine as fractions. But either way, that would be your exact answer. Hope it helps.